Hi, and welcome to But What If We Win with me, Zuri Horwitz. I ran for U.S. Congress in El Paso County, Colorado, because I believe very strongly that if Dems win, it isn't just about flipping a seat, it's about having actual actionable policies that will make people's lives better. It's people-centered policy rather than profit-centered policy. Because I just talked about this, I'm going to get into what we talked about in our last episode, which is kind of why I think really is an important framing, which is that the people controlling AI and big tech have huge financial stakes in their success and are some of the wealthiest people in our country who are also controlling our elections. So the information that we get about AI and big tech is heavily, heavily influenced by them. And we live in an extraction economy. And what do I mean by that? An extraction economy is about people who are wealth extractors, which are billionaires. And that makes them, first off, very one-note people because they, I believe, are like the kinds of people that aren't people with much depth. Maybe they could have depth, but they haven't gone on that journey, let's just say. And at this point in time, the US is the land being mined by these wealth extractors. And how often does that turn out well for the land? This hits a lot on data centers. This hits a lot on so many different things. This is going to be a very wide-ranging episode. So buckle up. We're going to go over why I believe data center bans are the best starting place for regulating AI and big tech companies. Local is best because federal and at the federal and state level, it gets watered down immediately, as we're going to see when we go over some of the other legislation in the second half of this episode, because there's so much big money involved. Whereas locally, we have a city council that doesn't get paid. Is it worth the headache? We'll find out with the Taurus data center. Is it worth the headache to have a data center in Colorado Springs with hundreds of people who will vote you out of office, who will make your life miserable for making their lives miserable? So that's why locally, I think it's better. The problem is, of course, the people that are able to organize are not going to be coming from disadvantaged communities. So that's when we talk about, data centers and where they've been built, they've often been built in communities that don't have an ability to do much about it. There is also a movement to ban data centers at the state level, and that is also a good one. We'll get into why, but I think it's all connected back to a lot of the information about data centers, about big tech, about privacy. That's coming from people with a vested interest to make a lot of money off of both of your information and off of integrating AI into situations that it shouldn't be integrated. So let's get back to what I think are the two central issues here. Well, I'll say three. Environmental, period. Electrical capacity and water capacity have huge impacts locally. We'll get into that a little bit more. And then the bigger ones for me, I think global warming is huge, but we're going to touch on that because data centers touch on it. But philosophically, the big issues are privacy and using AI and any of this big tech, any social media. Is it being used as a tool or is it being used as a cudgel? Is it being used to create a larger market share? Is it being integrated in ways that are actually useful for people, or is it not? And so in the past 3 years, I have only found one useful way of using AI. And let's get clear. Before I get there, we will define AI with this Girls Who Code article, which does a really great job breaking down the difference between traditional AI and generative AI, which is very, very important. We are just going to read from this article on Girl Code, really nicely done. So basically, in 1950, traditional AI is 70 years old. In 1950, mathematician and computer scientist Alan Turing published his paper Computer Machinery and Intelligence and developed the imitation game, also known as the Turing test, to determine whether or not machines can think like humans. like humans, I'm going to say this is really important. And I'm getting this from somewhere, and I'm sorry that I don't have the source. This is not an original thought. But thinking like humans isn't the right way to define it. It's, can you trick humans into thinking you're human? That's not the same thing. It's not the same thing as being a thinking human. You can trick people easily. You can look at a house and think it has a smile on its face. We like to humanize things. That doesn't mean that it's cognitively acting the same way as a human being. So basically by 1955, machine learning research was in full swing. And I want to find the podcast episode. If I do, I will tell you, but I think it's really important to have that definition. I'm going to try to find it. I'm guessing it's from Tech Won't Save Us, but don't quote me on that. Okay, so what is traditional AI? Traditional AI, also known as narrow or rules-based AI, works by using a set of pre-programmed rules, also known as algorithms, to make deterministic decisions. This means that given the same input, traditional AI will always produce the same output, following explicit logical rules defined by human programmers, a process that requires substantial expertise. Once these rules are defined, this type of AI will not operate outside the strict boundaries of its design. But within those boundaries, it can be an incredibly powerful and reliable tool. So let's use Arthur Samuel's checkers program as an example. His early AI worked because it was provided the strict rules of the game and allowed to run through trial and error scenarios. As good as it became at checkers, it could never play any other games unless Samuel also explicitly programmed those rules as well. But just because traditional AI requires explicit programming doesn't mean that it's not extremely useful, and it's all over the place. Traditional AI is the perfect tool for solving many of our day-to-day problems, solving domain-specific problems, and ensuring that consumers and industry technologies are both reliable and predictable. In fact, if you're reading this blog post, odds are that you already use traditional AI hundreds of times per day when interacting with the digital world. So let's take a look at examples of what that might look like. Streaming services that suggest movie recommendations based on what you've liked in the past. Email platforms that automatically filter out spam. Search result rankings on your browser. Now this is really important because right now we're getting generative AI, and then I've been noticing a lot that when I look up a news story that I've seen on Instagram to verify it with facts on both DuckDuckGo and Google, I'm getting very, very limited news results. So that's telling me that their filtration system is not for knowledge. It seems, at least from what I'm experiencing, to be optimized for selling you stuff, for ads. Fraud detection services from your banks, continuing medical diagnostic systems that help doctors identify diseases based on symptoms and test results, GPS navigation systems that calculate optimal routes based on traffic. So now let's go into what is generative AI. Thank you guys for standing by with me. But I didn't feel like I could bring up my example of something that worked without us defining what we are talking about when we talk about AI. When it comes to artificial intelligence, generative AI is the new kid on the block. Unlike traditional AI, which follows deterministic rules, generative AI operates probabilistically, meaning it generates outputs based on the statistical patterns it learned, with some degree of randomness built in. Some people say like 20%. And, I think we've all experienced search results that have not been accurate. And also, it depends. We're going to get into it a little bit more. But it's important that the inputs that they're trained on have to be good. So if we're no longer funding scientific research, if we no longer have search results that are filtered for best information but are instead optimized for ads, generative AI is training on that. So it's becoming worse. And I also believe it can become a snake eating its tail, where it's just training on itself, and it's not creating anything new. It's not learning from new, good quality information. And so trash in, trash out is how I feel. So let's go. The learning process involves analyzing enormous data sets to build neural networks, machine learning models that, when trained, can generate entirely new content by predicting what should come next based on statistical patterns. But again, it's just pattern making. It's a new version of trial and error. So traditional is built on rules. You give it the rules, and then that algorithm follows those rules. This input is data, and so it uses probabilistic outcomes based on the data. It's not really creating anything new. Generative AI is and why isn't it creating anything new if it's not coming from its perspective? We'll get into it. It's messy. Generative AI is a fairly recent development, exploding in popularity with the emergence of large language models and tools like ChatGPT and Claude. Nowadays, AI companies are able to build a vast... Okay, but let's go into the probabilistic nature of generative AI means that the same input can produce different outputs each time, allowing for creativity and variety, but also introducing some unpredictability. This is where I'm like, what is happening? Here are a few examples of generative AI used today. Text generation apps like ChatGPT, Claude, and Bard. Image generators like DALL-E and Midjourney. AI coding tools like Curso and GitHub Copilot. Voice synthesis tools like 11 Labs. Yeah. Okay, while these tools are extremely helpful, generative AI does have some downsides. Some companies have recently come under scrutiny for training learning models on other creators' works, and many others are worried about becoming too reliant on AI and losing our ability to think. So let's get into this a little bit more than I thought. This is going to be a long episode, but I think it's really important that a lot of what AI is doing is the easiest part, and it's also short-circuiting thinking. And this will eventually get into my final example of an AI that was useful. And who knows if it needed, yeah. When you are writing, it is difficult and it takes a long time as somebody that is not a fantastic writer. Part of writing is brainstorming, which AI does kind of well. And then it's all fact-checking and editing to make sure that you have a coherent thought. So giving that to AI is skipping over checking sources, understanding the literature. And what is the literature? The literature is, if you're studying health, going into studies and seeing if it's a quality study. Is it a good study? Is it quantitative? Is it qualitative? What type of quantitative? What type of qualitative? Where are the gaps? And while AI can give you some kind of summary that might be a good starting point, if it's being trained on poor studies, if we're not prioritizing as a society good academics, if we're not prioritizing, funding science that is being performed at a high level, it's not useful. It doesn't matter. AI is just kind of like a summary of what's there in a kind of random way. We saw that with Midjourney, where they'd have like styles that were just mimicking other artists. They weren't really creating like a new style. It was just mimicking other artists to a degree. And that might work that might work in a movie. That's okay, but again, it's a tool. And so let me talk about the one example that I have. Oh, here, let's keep going in this, and then I'll talk about my example. These two types of AI systems also differ in another crucial way: their effect on the environment. Traditional AI systems don't rely on complex neural network computations, so they typically use significantly less energy and resources. One second. And resources. Generative AI, on the other hand, requires enormous computational power for both training and operation. Training a single large language model often uses the same amount of electricity that hundreds of homes use in a year, and the process requires huge amounts of water resources for cooling data centers. Now, there's a very small minority of data centers that use a closed loop, but that is not the majority of data centers, and we're going to talk about that gap here. in my next, I have my little example. I have Colorado Springs as a case study, and then we're going to go into regulations that aren't regulating data centers, that are more AI regulations and privacy regulations and social media regulations. Even running generative AI application requires more energy per query than traditional AI tools. In certain cases, generative AI can be used to help the environment. I'm going to look at that example. That said, it's still important to consider resources demands when deciding which tools to use. And what I like, okay, let's see, eco-conscious. Yeah, again, they're saying these things. The World Economic Forum said we can use AI tech to transform complex systems, make power grids, making them more efficient. But they're saying that, but I'm not to optimize wind farms. Okay. But again, now let's get into my example. So finally, I had a use for AI. After 3 years? Apple Podcasts does this thing where it will have a full transcript running, which can be very annoying while you are listening to the podcast. And so when I was listening to the Pitchfork Economics podcast, I heard Nick Hanauer, or whatever his name is, talk about Jeff Bezos being super special. And I couldn't remember the exact wording. So I used that tool to search the podcast, and I was able to find the quote, I think. I did not go back to the exact point and listen to it. So that was not as good screening as I could have had. Anyway, thank you for holding on. We're already 16 minutes in. We've got so far to go. 17 minutes in. But yeah, so I want to talk about that because I said earlier that the keys are privacy and using it as a tool. Now, it would have made sense if I wanted to find that to go to a tool on the internet and input that podcast episode and have them scan it to find it. Okay, limited. But why are we using all of that extra computing to have a transcript for every podcast on Apple Podcasts? That to me is about enriching AI companies, and that takes it out of the realm of being a tool. Because it's not being used in a nuanced, specific place. It's just being used generally in order to flood the marketplace and to try, like spaghetti being thrown at the wall, to see what sticks. And I think I want to do another episode, and I've talked about it a little briefly, but I think it's important to talk about how this has been being advertised to us from the perspective of a tech CEO, rather than coming from a place of using AI in a way that's actually useful to people. Right now we have students using AI to replace getting educated. That is not useful. Being able to make a query as a starting point for your essay and then fact check it, useful. But these generative AI, these data sets that they're using need to be heavily looked into and regulated by a human being to ensure that the output is good. Because if, again, garbage in, garbage out. If these same tech companies that are so excited about generative AI are also squashing scientific research, if they're also squashing, good search results, if they're being optimized for ads, if they're being optimized for a certain perspective, and most likely because they're getting rid of white collar workers and appears to be blue collar workers with robots, it's for the benefit of billionaires, and the perspective and the way that they are generating data is for them. It is not for the greater good of people using that data. And I think that's really important to look into. So let's go into why we need privacy. We need to use AI and big tech as a tool, not as a barrier. And let's go into why I believe data center bans are the best starting place for regulating AI and big tech companies. At the federal and the state level, because of so much money, and this even happens locally, all of that legislation gets watered down. I've been following Tech Won't Save Us, Power User, 404 Media, and what I'll hear in one episode, often in Power User, they'll talk about, oh, there was this very good California legislation. There was this very good AI legislation in Europe. And then it gets watered down by the end, and it no longer does what it's supposed to do. And of course, the downside is that but if you live locally, if you're dealing with this locally, you can easily be removed. People will hate you. People will give you stink eye in the grocery store. You will have to move. If you screw up and you put a data center in, as we've seen in Colorado Springs, and that's going to be our case study, hundreds of people show up. People are not happy with this. People will not be happy with you if you put a data center into their community. So let's look at what is being touted as good science around data centers. And I'm sorry to put this article on blast. It's by Dr. Len Naseffer in Outside Magazine. And it kind of poo-poos a lot of, it poo-poos a lot of concerns, especially about water. I work on the Colorado River water for a living as a filmmaker and storyteller. I have a PhD in engineering and public policy. So he's like, I'm, really quality. And so he just looked at, for 11 weeks, an iOS app, and how much it took, the total life cycle water footprint of all that work was. And he said it was 5 gallons. And then he compared it to other things that take up a lot of water. But I think it's really important to base, where did he get how much that water is costing? And it says, and now he talks about inference efficiency, meaning how much energy it takes to actually answer a single query is improving dramatically. But that's also, first off, expecting that the only AI use that he has is about a query that he's using. Because I can tell you, as somebody that doesn't use AI at all, it's still coming up in every one of my Google searches. It's still coming up when I use a podcast. It's still being integrated often in everything that I do. So that is not just one query. It's integrated in everything that I do. It's integrated into when I call a call center. It's not just my few queries into this. It is permeating my life when I call my insurance to find out about whether something is covered. It's not just my queries. It's all over my life. So I felt like that was a very disingenuous look. And then also, he's including a 2025 Microsoft research paper, which found that combined advances in hardware, software, model architecture can deliver 8 to 20 times reductions in energy per query. The cost of running AI systems comparable to GPT 3.5 dropped more than 280 times between late 2020 and late 2024. Hardware efficiency gains are running at about 40% per year. Where's this coming from? Microsoft. Microsoft is heavily invested in AI. Yeah. Okay. And so let's look at and then he has like we'll look into this because even the International Energy Agency's 2025 Energy and AI Report projects data centers will account for roughly 3% of global electricity by 2030. That is worth monitoring, not a crisis. Okay. So let's get into that. And I'm going to have to look out about build up. I'm going to look into this publication because I think it's important. Read the original source of this. Let's see the executive summary. I'm trying to find out who sponsored this. Okay, data center electricity consumption is set to more than double to around 945 TWh by 2030. This is slightly more than Japan's total electricity consumption. AI is the most important driver of this growth, alongside growing demands for other digital services. And the US is like at the top, followed by China. Okay. Data centers account for around 1/10 of global electricity demand growth to 2030, less than the share from industrial motors, air conditioning in homes, offices, or electric vehicles. However, the significance of data centers in driving electricity demands differ by country. Emerging and developing economies are already experiencing rapid electricity demand growth. So in those countries, data centers account for more than 20% of the demand growth in 2030. Yeah, okay. Yeah, and again, I need to find who sponsored this. Yeah, this is very... The industry, yeah, this is... I just have to find out who's paying for this. Isn't that interesting, though? Usually, if it's a study, you would say, let me see, download PDF. Let's see if that's better. But it's always really important, thanks for coming along on this journey, to look at who paid for this. Because, and this is what I'm also going to say that I think is really important. People say, well, all this other stuff uses way more water. Yes, that can be true. However, okay, good. So this is the International Energy Agency. So that's generally, okay, that's European Commission. It also includes Argentina. Yeah, so it's, okay, so it's not a totally terrible report, which is good. I want to, as far as I can tell, I just want to make sure, because again, these things can come off as being super, perfect. This is also a 304-page report, so I'm not going to be able to go through it all in depth at all. But okay, so what I wanted to, let me finish my thought. This is a new use of energy. We can have better standards around it. I also think it's new. It's a new use of energy. A lot of the information is not there, and a lot of it being provided is being provided by big tech companies. So I have to look at, like, where is the information coming from? Because we are building these data centers new, and what I'd really like to see is, is making sure that, when a data center is put in, how much energy consumption was there, and now how much before, and then how much energy consumption afterwards. How much water was consumed before, how much water is consumed after. So, and I also want to, a little bit of my skepticism is that there was going to be a very highly regulated AI legislation in the EU, and then it got watered down. So I'm like, who had their hands in making this? I know, I'm fun and a conspiracy theorist. Not really. Let's look at annexes. Let's see if that... Okay, let's do the acknowledgements. This is so frustrating. Because they say who these people were. Okay. So let's see the peer reviewers. Indian Institute of Technology, Delhi. Crusoe. Luffy AI. Hitachi Energy. Let's look up Alpha Laval. Alpha Laval, the leading company for energy efficient heat transfer and separation equipment. So I'm a little skeptical because OpenAI, Google, Siemens Energy. There's also, MIT, Rogan Center for Sustainability, Switzerland, Amazon Web Services, permanent representation of Poland to the OECD, Department of Natural Resources Canada, Microsoft, Kumi Analytics, OVH Cloud, Ericsson, Total Energies, Hess Corporation. So these aren't, there are some colleges and countries overseeing it, but there are also a huge number of corporations like Cisco, Chevron. Oh God, you're reviewing this. Oh my God. Okay, so that is very funny. Oh, didn't it take a while? It really took a while to find it. Oh God. Okay, that is so funny. IBM, Meta, they're peer reviewing. They're peer reviewing energy and AI. The people with a direct financial. Oh God. They're peer reviewing how much energy and water, I think this is mostly focused on energy, is required. Oh, God. Okay, so now let's look at somebody that doesn't have a vested interest and what they're saying about it. We're going to go to a Consumer Reports. So this is a consumer report. We're just going to go through it quickly, read through it. It's really great. AI data centers, big tech's impact on electrical bills, water, and more. It starts with this. John Steinbach was shocked to receive a $281 electricity bill in January, a huge spike from the roughly $100 he'd paid the previous month. See, this is the information I want. If you live near a data center and your bill nearly triples, that's the information I want. That's the information that I think is very important. And I mean, I know a higher bill is just a reflection of this, but let's talk about, to meet this ballooning demand from AI, tech giants like Amazon, Google, Meta, and Microsoft, many of whom were peer reviewing this energy and AI report, an AI report. Oh, I mean, I am sorry. My cold heart is laughing at this. So right now, 3,069 data centers already operate in the United States with an additional 1,489 planned or under construction. That is a friggin' problem. And that is where we need to have a moratorium, because these are being put in, and a growing number of them are hyperscale data centers driven by the AI boom. These sites can sprawl across thousands of acres and consume vast amounts of power. Shown here are 68, and they have great maps here, 68 hyperscale facilities that each use at least 50 megawatts of electricity, as much as a small city. Come on, we're supposed to pretend that this isn't going to be a problem. The boom is just getting started. There are 267 planned data centers, each using 50 megawatts or more. Meta's Hyperion campus in Richland Parish, Louisiana, a poorer area, covers 3,650 acres, twice the size of New Orleans' main airport and 4 times as big as New York City's Central Park. So when you talk about AI, go to this article. This article is not here. It's Consumer Reports. It's to protect the consumer. It is more likely on your side than a really long 300-page report put together with the peer review of the companies with a vested interest in making a bunch of money. So, yeah. And we know what's going on in Utah with that giant AI center. And let's go look at electricity bills are rising. It's no secret that electricity costs across the U.S. are skyrocketing. Residential prices jumped 7.1% in 2025. And keep in mind, the Trump administration has a vested interest, has decided to stop funding solar and wind and other renewable technologies and go back to gas and oil. So we are going away from better, more efficient technologies that will cost us less to costing us more while we are dealing with AI. That 7.1%, there was a residential prices jumped 7.1% in 2025, more than double the inflation rate, and topped 20% in some states, according to federal data. The AI data center rush isn't the only factor driving up prices, others including inflation and an aging power grid, like we just said. That's because hyperscale data centers demand a nearly unimaginable amount of energy. Okay, so this is from the report, the International Energy Agency. Let's see, let's make sure I know. I just want to make sure. Yep, so that is from that report, or from that organization. It says a typical hyperscale data center might use 100 megawatts, as much electricity as 100,000 households. How are we acting like that's just going to be a small percentage? And that's at the low end. Meta's Hyperion project in Louisiana, for instance, will need at least 5 gigawatts to run. That's 3 times as much electricity as the entire city of New Orleans, according to the Institute of Taxation and Economic Policy. And so we're going from power demand, all U.S. centers, 80 gigawatts in 2025 to projected in 2028, 150 gigawatts. That is a lot. That's nearly doubled. By 2028, data centers could use 12% of all the electricity consumed in the U.S., according to the Lorenz Berkeley National Laboratory, and that percentage will grow. More regions could start to look like Virginia, already home to 600 facilities, with more than 100 more proposed or under construction. According to a Bloomberg News analysis, data centers accounted for almost 40% of the state's total consumption in 2024. So, yeah. More data centers can mean higher costs. That same Bloomberg analysis found that areas with high concentrations of data centers saw electricity prices jump 267% over the past 5 years. And again, I want to see that. Nearly 3/4 of voters in the state blame the facilities. Now, is that always the case? Who knows? But I think if we could have a before and after study, and, it would be helpful. But this is useful, and I like that they're drawing from a lot of different sources. They were drawing from a lot of different sources in that other report, but that report was being overseen by companies with a vested interest. Water demand is soaring. Large data centers, rows upon rows of stacked servers and other hardware, operate around the clock to power intensive computing tasks like generative AI and cryptocurrency mining, and they run hot. To prevent the machines from overheating, the facilities have historically relied on constantly circulating water to cool their equipment. In the process, a data center can use up to 5 million gallons of water every day, as much as 16,000 plus average U.S. households, according to the Environmental Protection Agency estimates. The EPA. And right now we have an EPA that's been very hollowed out, and at the federal level is not incentivized to go after issues that are concerning the environment that will make us sick. That's just direct usage for cooling. Generating the electricity to keep data centers powered up requires additional millions of gallons of water, even more than the water used for cooling. Direct water use by Phoenix area data centers, 385 million. So miss me when they say that that they're not going to use that much water. And oh my God, this is insane. From Ceres and the EPA, the facilities in Phoenix water consumption may skyrocket to 3.7 billion gallons annually. That's enough to supply 34,000 homes. It's also insane. It's in Phoenix. It's also Colorado Springs. We have water issues. Hyperscale data centers can worsen water shortages in regions already hit by the 25-year mega drought. Phoenix, this is very relevant to us, draws 40% of its water from the Colorado River, where we draw our water in the El Paso County area. The system's 2 major reservoirs, Lake Powell and Lake Mead, have fallen from roughly 90% capacity in 2000 to around 30% today. We should be investing in solar and wind. Phoenix And Colorado, we have tons of sunny days. We have wind power. And instead, we have people stuck in the 1980s who are increasing our water and electrical capacities. What's more, about 2/3, this is from this article, about 2/3 of the data centers built since 2022 are in areas already experiencing water stress, according to a Bloomberg News investigation. That includes parts of Texas. The state is already home to roughly 400 data centers, according to Data Center Map, an industry research company, and is now contending with the introduction of massive campuses. One planned site, called Project Matador, will house 18 million square feet of data centers, plus 4 nuclear reactors and natural gas power plant. The developer, Fermi America, let's go back. Let's see our little oversight. Was Fermi one of them? Let me look. I could be wrong. Sorry, you guys. Thanks for having patience. I just think it's interesting. Okay, I'm not seeing Fermi. Doesn't mean it's not there because I'm just going through this quickly. Okay, I'm not seeing Fermi in the people that are overseeing the energy and AI report. Okay, in Arizona, another water stress state, companies have built or announced plans to build 26 data centers since 2022. I mean, yeah, so this is a terrible idea. And when people say, oh, it's not going to cost energy, it's not going to cost water, they are lying. They are lying. And maybe it's just a smaller percentage compared to other things, but these are very, very huge increases. And we don't need them. And we also need to be, again, generative AI may have its uses, but it is being integrated not just into your single query. It is being integrated to all web searches. It is being integrated into every podcast you listen to sometimes. It is being integrated whenever you call a company. So no, it's not just your queries. All right. Data center deals are often secret. When a company wants to build a data center in a community, its residents are frequently kept unaware of what's coming until the project is a done deal, which we don't do with solar and wind. Okay. All right. So now let's go to, I think, an interesting look at this gap. This is based on No Data Center COS in a recap of the data center meeting with Raiden, which is trying to build a data center in Colorado Springs. So, Raiden has reported that they do not plan to use this, that they instead plan to use 200,000 gallons only once for the data center. However, 1 million gallons per day is permitted for use at the site that they want the data center. Nothing legally prevents Raiden from using up to 1 million gallons of water per day. All we have is them saying that they will only use 200,000 gallons once. Why would we believe them? And we could go in and maybe it's closed circuit and they have some magical thing. I just don't trust them. Raiden can also be a candidate for a special utility contract. Raiden highlighted that they would be subject to a large load tariff where they would pay a higher rate for the electricity they use. However, Raiden would still be able to get an economic development special contract. This would allow Raiden to enter a deal with Colorado Springs Utility that would decrease the impact of the large load tariff or supersede it entirely. Both Raiden and Colorado Springs Utility said that they will not be pursuing a special compact, but nothing is disqualifying Raiden from pursuing one at a later date. There is also no data on the possible heat island effect. The heat island effect is when an area has a higher temperature than its surroundings. Jason Green reported that Raiden did no heat island effect studies, and they would not know impacts until they know which chips are going into the data center. it is more likely than not that the selection of chips and equipment wouldn't be decided until after the AI data center is approved. Okay, and then also previous complaints about the site went unheard. From 2018 to 2020, the location of the proposed data center was the home of a Bitmine coining factory facility. At the community meeting, multiple residents cited that during the facility's tenure, there was minimal response from the city when they complained about noise. The facility shut down eventually after the company filed for bankruptcy. Okay, so I think it's really important. We have these non-binding, there's the gap of what tech companies say they're going to use and AI data mining companies say that they're going to use, and what is possible in the facility that they have put their data center in. So they might say, oh, we're not going to have that compact, but they have nothing that's stopping them from having that compact. They might say that they're only going to use 200,000 gallons of water once, but they have 1 million gallons of water available to them daily. Let me make sure that I'm saying that right, because that's crazy. 1 billion gallons per day is permitted for them in Colorado Springs, which has where we cannot water our lawns, and we shouldn't be watering our lawns. That's not the climate for it. Anyway, I was gonna go over all of the different legislation, which I think is really important, but this is already 46 minutes long. So we're gonna be doing this today. And then we're gonna go over legislation, and I'm gonna try to get into a little bit of how that legislation changed with input from AI and big tech companies. Not gonna be beautiful, not gonna be perfect, gonna be me researching on the fly, but I think it's really important. And I wanna close with this. And I'm gonna look it up because you have to look it up. Is that what big oil knew about climate change? When we hear these guarantees from these companies with a vested interest, from these people who come from an extraction point of view, we have to remember big oil. This is so depressing. Actually, this is worse than I thought. This is from an article from Benjamin Franta in The Conversation, What Big Oil Knew About Climate Change in Its Own Words. At an old gunpowder factory in Delaware, now a museum and archive, I found a transcript of a petroleum conference from 1959 called the Energy and Man Symposium, held at Columbia University in New York. As I flipped through, I saw a speech from a famous scientist warning the industry executives, warning the industry executives and others assembled of global warming. Whenever you burn conventional fuel, you create carbon dioxide. Its presence in the atmosphere causes a greenhouse effect. If the world kept using fossil fuels, the ice caps would begin to melt. I also am going to go to another reference. Because a woman discovered, well, there's like a number of people. There's so many. It is so bad. So the first time the existence of the greenhouse effect, while not named as such, was proposed as early as 1824 by Joseph Fourier. The argument and the evidence were further strengthened by Claude Poulet in 1827 and 1838. In 1856, Eunice Newton Foote demonstrated that the warming effect of the sun is greater for air with water vapor than for dry air, and the effect is even greater with carbon dioxide. We've known about this for years, but let's just talk about oil and gas knowing about this. In 1959 was before the moon landing, before the Beatles' first single, before Martin Luther's I Have a Dream speech. In Wyoming, I found another speech at the University Archive in Laramie, this one from 1965, and from an oil executive himself that year at the annual meeting of the American Petroleum Institute, the main organization for the U.S. oil industry. The group's president, Frank Ickard, mentioning a report called Restoring the Quality of Our Environment that had been published just a few days before by President Lyndon Johnson's team of scientific advisors. The substance of the report, Ickard told the industry audience, is that there is still time to save the world's people from the catastrophic consequences of pollution, but time is running out. One of the most important predictions of the report is that carbon dioxide is being added to the Earth's atmosphere by the burning of coal, oil, and natural gas at such a rate that by the year 2000, the heat balance will be so modified as possibly to cause marked changes in climate. And haven't we lived that? So when you hear from tech companies, from AI companies, that it's not going to cost us water, that it's not going to cost us energy, I would take it with a huge grain of salt. Huge grain of salt. All right, thank you for listening. Next week we'll go over regulating AI. This was much more about the climate impact than I had realized. And I will share my sources in the description. And thank you for listening. All right, bye-bye. And of course, an addendum, I would also like to talk about how we input cars, which is very much connected to global warming. We put in cars, we put in paved roads, we paved over nature without and ripped up trams and ripped up trains all across our country, which are much more efficient and and last a whole lot longer. Part of what always happens when it comes to, this is just from me spitballing, part of what always happens with trains and why I think they end up becoming really, really bad is that they last for so long. There's an initial huge investment and then they can run very, very well with less investment than you can with roads. So you're not constantly paying for new roads. You're not constantly paying for new paving because it lasts. Like, you have right now, we have like in New York City, they're still using subways from the 1970s. It is 50 years later and they are still using those trains. And yes, they need to upgrade everything, but that's what always happens with trains is they last for so long that they can kind of be neglected in a way that you just can't with roads because you would not be able to drive on the road because the road would not be there if you did not consistently pave every 10 to 20 years. But with a train, you put in a train track and with minimal upkeep, not necessarily meaning it's a great ride, not necessarily meaning it's really fast, you can have the train on there. I mean, and part of our huge problems in the accidents that we've had are train companies cutting back on the bare minimum of people on the train and the bare minimum of safety to make more money. But you can't really do that as much with a car, and cars are already 10 to 25 times less safe than trains, but you can get away with quite a lot with a train, but that you cannot get away with a road. So when we hear about big tech and inevitable tech, and I'm taking this from Tracy McMillan Cotton, I think, it is not inevitable. It is not inevitable, and it can be a tool that can be used, but it has to be a tool. And we have to be very clear about the environmental impacts, and we have to be very clear about what it is actually doing and whether it is actually useful. And it can be useful as a tool, but it does not need to be plastered over everything. It does not need to come in instead of human beings. In fact, it is often a watered down version of what a person can do. And it needs to be overseen to make sure that it has good data. Because again, garbage in, garbage out. And then we've got garbage in, garbage out, and we're ruining our local environment. So yes, there's also a petition going around. Please sign the petition for a data center ban in Colorado Springs, and I would argue El Paso County. There's also a link to states that have data center bans. I think we should have a data center ban in Colorado. As always, we want to talk about what the actual policy is, and we need a data center ban in Colorado because right now we are using it all over the place. It is not just your few queries that you are using. It is all kinds of queries. It is all kinds of interactions that we don't even necessarily want, that we are not asking for. It is in my Instagram. It is in my Meta. It is all over the place, and it doesn't necessarily need to be integrated in that way. It is being used to replace systems that worked before for much more heavy water intensive and electrical intensive uses. So thank you so much. Bye. Back next week with more.